In match problem 3, we're given the function f of x equals x squared. And in part A, we want to find the slope of the secant line for a equals 2 and h equals 2. And then also for a equals 2 and h equals 1. So we'll start off by considering a equals 2 and h equals 1. So we'll come back to the definition for the slope of the secant line, which is f of a plus h minus f of a over h, and then substitute in our values. So in this case, a is 2, h is 1. Oh, I'm sorry, that should be, we're starting off with a equals 2, h equals 2. So a is 2, h is 2. So this is f of 4 minus f of 2 over h, which is going to give us 4 squared, since we're taking that value for x and substituting it into x squared, minus 2 squared, all over 2. Oh, and we could have made that substitution a step before. So all over 2. So here we get 16 minus 4 in the denominator, or in the numerator, divided by 2 is going to give us 6. So the average rate of change of our function at a equals 2, h equals 2 is 6. So now we can consider when a equals 2 and h equals 1. Similarly here we'll have f of 3, since that's a plus h, minus f of a, which is 2, all over h, which is 1. So we're still substituting each value for x into the function x squared. So we get 3 squared minus, and I apologize, I keep mixing up these numbers, f of 1, meaning here we're going to be subtracting 1 squared, divided by 1, is going to give us 9 minus 1, which is 8. In part B, now we want to find and simplify the slope of the secant line for a equals 2 and h is any non-zero number. So in the previous two examples, h took on a specific value. H was 2, h was 1. So now, instead of being given a value for h, we want to come up with an expression for any value of h, as long as h is not equal to 0. So this is going to be f of a plus h minus f of a over h. We're given that a equals 2, so this is going to be f of 2 plus h minus f of 2 divided by h. So we're still substituting into the function x squared. So this is going to be 2 plus h, that quantity squared, minus 2 squared divided by h. So now what we want to do is expand 2 plus h squared and see what we can simplify. So this is going to be 4 plus 2h plus 2h plus h squared minus 4 all over h. So here 4 minus 4 will cancel out. We'll be able to add 2h and 2h, which is going to leave us with h squared plus 4h over h. We can factor out the h in the numerator to rewrite this as h plus 4 over h. H over h cancels, and this final reduced expression that we're left with is h plus 4. So when a equals 2, now we can plug in any value for h and come up with the slope of the secant line. In part C, we're being asked now to find the limit of the expression in part B. So we want to take the limit as h approaches 0 of h plus 4. We have a polynomial function, so we can apply direct substitution, which is going to give us a limit of 4. In part D, we want to find the slope of the graph and the slope of the tangent line at a equals 2. So the slope of the graph at x equals 2 is the slope of the tangent line at x equals 2. So what we're saying is when we talk about the slope of the graph, the rate of change of the graph, that's exactly the same as finding the slope of the tangent line at that point, is the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h, which up above we reduce that to the limit as h approaches 0 of h plus 4, which we already found to be 4. So the rate of change of our function, the slope of our graph at x equals 2, is exactly 4.